need to call it a container. It's like it's a reflective.
Well, is it containing the radio waves or not?
Well, it's reflecting them. I don't think that it
Okay,
stops
why
all of
aren't they
them.
going beyond it?
Do they not?
Depends on the frequency.
Right.
Yeah. So if you're saying there's certain frequencies of waves that are contained by the ionosphere.
Okay.
Okay. How do I test your claim?
I don't know. I don't know. I don't know how to test that one.
So you're in the business of science is all about falsifying things, and you never thought about how to falsify the science you believe?
I've never claimed that I believe in the globe because I scientifically proved it. It's not why.
No, I agree. You I think claim that you don't know anything.
Well, more specifically, I said that the story works better for me. It literally just is a more coherent story.
Yep, and we went over that, right, with the scripture and everything.
We just went over this. What's more coherent, right? The one that can be demonstrated in nature and observed, or the one that can't be demonstrated in nature and observed, both deductively and what's the second? Whatever. Go ahead, dude.
You guys have fun with the unconscious Mason. Bye.
Later, CA.
Yeah, no. The story where it's like, well, the sun goes far away, and I can't say where, and I mean, I'm sort of like overstating it, but I mean, like, there's just like gaping holes, and with the stuff in the sky, we're working on it. Like, that just doesn't work for me. Like, get it together, and then pitch it to me, and then I'll consider it. But if it's just like we're working on it, then it's like, well.
But you agree we can't use the empirical
Figure
method
it
for
out.
the stuff in the sky, right? Like no one can tell you what the moon is empirically, right? It's not like you could go there.
Tell me a good story about it that I can buy, and I'll buy into it. I'm not saying that I'm a scientist who proved that the moon is a
Genesis
sphere.
1, bro.
I don't like that. That story sucks.
You know how many impossibilities there are in your model that it basically invoke God to the point now it's just a multi-universe ordeal?
Yeah, but I like that one better. I don't like the Jewish God at all. I think it's just like weird.
But
there's a guy in your story whose strength came from his hair, my guy.
Before we change topics.
Strong. I got long hair.
Yo, I remember what I was going to say. So yeah, so your conception of the vacuum of space next to an atmos with pressure, even if there's a gradient pressure, that concept can't be inductively it can't be inductively reasoned or empirically demonstrated. I wanted to make sure I said it correctly. And yet you appeal to it consistently. Ours, at least we have inductive reasoning on our side. And natural observations. You don't.
Yeah,
and that's just the bottom line.
Okay, and that's fine. If that makes you feel better and you know, okay. But it doesn't make you more right. It just it's like, all right, you've done some logic things with your words and your systems, and you're like using this system of reasoning, and you're justifying a belief in a way that appeals to you.
No, I want to make sure that you concede.
I feel this justified is a concession, by thinking about it this way.
But this is a concession, and then we can move on to the next topic. That what you're appealing to and what you're promoting, this vacuum of space, cannot be falsified. It cannot be inductively reasoned, and it can't be empirically substantiated.
Well, I mean, all right. If you're going to say it that way, then I have to go like, bro, there's dudes going out there and checking it out. And then you just say, no, they aren't.
You don't know that they are. It's not that we know they aren't. It's that you don't know that.
But the way he phrased it is that it can't be checked. And it's like, well, I believe that it can, and you believe that it can't. I believe I could go in a, spacesuit and in a spaceship and go out there and check it out. And you believe that's impossible. So we just have different beliefs going on.
They've been doing it since '69, bro, and they haven't even gone back to the moon. It's the only technology in the world that goes backwards, bro. It's getting worse as time goes on.
That's fire rhetoric, but that doesn't really disprove anything.
No, that's a really
they're
big
up
issue.
They're up there in the ISS right now, I believe, and you say they aren't, but I mean they're up there in the vacuum.
Well, okay, that's Earth
that's
orbit,
a really
dude.
big issue.
You got 250 miles. You never drove 250 miles, dude. I could do that in like 3.5 hours.
Then go for it. Get up there and check it out for yourself and find out how much
I'm
pressure
talking
there
about,
is.
dude. Think about the distance in comparison to 240,000.
No, but are we talking about gas in the vacuum, or are we talking about the moon? That's a different conversation.
No, you've moved the conversation into I believe people go to Narnia because I watched it on the television.
No, I didn't say anything about
That's
the
what
moon.
you've
He
moved
said
the
you can't.
conversation.
He said you can't empirically verify the vacuum of space, and I'm saying there's guys up there right now doing experiments in the vacuum of space. So he's
according to my
verify.
television. Yeah, according to your television.
Claim. According to
right,
your claim.
And you're saying I think that's all fake, and so.
But I don't even necessarily negate the. I don't necessarily negate the idea that there is low pressure up there. But you can.
Well,
the thing is, you can
is.
have a gradient change inside of a containment or a container. Like, let's say you had a container on the Earth that went up to the edge of space, or what you consider to be space, the Kármán line or whatever.
But wait a minute, can I stop you? I don't mean to interrupt.
And within that, hold on, within that container, you can have a gradient going all the way up.
But not all the way to 10 to this negative 17, right? Why not?
And end up hitting a wall. No, you can end up hitting a wall within that low pressure.
A wall?
Yeah, a structure, crystalline structure.
You mean like above the space station?
No, anyways, you get what I'm saying, bro. Yeah,
I guess my point is like you admit that the pressure goes down as you go higher. But then you're like, it can't go down that much to 10 to the negative 17. I'm like, well, why not? That's just down really far. It goes down, all the way down to really, really low. It doesn't go down to zero. It just goes down to really fucking low.
No, I get your point of view, bro. I understand it very well. But you can't demonstrate that. That can't be falsified. It can't be verified. It can't be falsified. It can't be demonstrated. It's a concept. It has some type of logical adherence, right? I'm not going to completely take that away from you, but at the same time, at the end of the day, we're dealing with concepts. Which one's more logically coherent?
We're looping
and inductive. And my position is, you're saying that there's guys up there that have demonstrated low pressure. Yeah, I know. I agree. There's people that have been up there, and it's low pressure, objectively, no doubt.
There you go.
That's not a rebuttal. Sorry. It's not an argument.
Well, you said it can't happen without a container. And I'm saying, well, show me what we're experiencing now in a container. You can't reproduce this thing we're experiencing now in a container either. You can't show me a container that has 14 plus PSI on one side and then next to nothing at the other side, and it stays there stably like we're experiencing now. So you can't demonstrate it, neither can I. So neither of us has one over on the other.
No, it's about process of elimination. Which one is more logically coherent, bro? Do you not understand that?
He doesn't care about logic, it seems.
No, I'm saying yours isn't any more than mine because you can't demonstrate yours any better than I can demonstrate mine. I told you mine. Your answer was, "Can you demonstrate that?" And I said, "You can't demonstrate yours either." So why does that matter?
He said the laws of logic come from language because language was formed. Therefore, the laws of logic came about. That would make them subjective in nature. So, and they're not. They're objective. So, he's living in a world that doesn't have to have logic. Then he doesn't have to have a logical answer for you, bro.
No, I'm no. I
What
think
are
mine
you
is
on
totally
about?
logical, coherent.
Hold on, buddy. What are you on about with us not being able to demonstrate this? Like, do you have a car? Do you have car tires? Yes or no?
What?
We can demonstrate gas pressure requiring a container. You have car tires. You have inner tubes. We have
no. You misunderstood the question. My question was, can you show me a container
No,
that has
I'm
14?
not responding to any question. I'm responding to a statement that you said it was false and stupid as fuck.
Well, you misunderstood the statement. And you're calling it stupid, so that's where we're at.
No, I already brought up induction,
false statement.
inductive reasoning. I already brought that up, and that's
False
what you're
understanding.
referencing, bro. Like we see all over nature pressure on the containment, right? We see that, we can observe that. That's inductive. He's asking for verification of this crystalline structure, which I don't have.
No, I'm not very.
But
No.
So, but that's where you use that against me. You're like, oh well,
No.
you can't demonstrate yours either, bro. I already conceded that, and
I'm not
that's
asking-
your rebuttal. It gets frustrating when people do that and they can't
You're totally
follow
misunderstanding me
a
still.
logical sequence, a syllogism. They don't know how to follow a syllogism. They're like, it's like dealing with
You're just
people
like
who
complaining and
no,
looping.
no, it's
You're
not, bro. It's
addressing
not
me.
because this is why philosophy is important. And
Oh
people
my God.
they get
This is
lost. They
gonna
get
tear.
lost in the sauce because they
I'm
don't
gonna-
know how to. They don't know how to have a.
If you're just gonna
philosophical-
cry, this is not gonna go anywhere.
Nah, bro. Because this isn't a proper debate, dude.
You're
It's
not
like
addressing what I'm saying.
I am, dude, and
No,
you're not. Every time I address it, bro, it's like you revert back to some
Well,
low
then tell me
level
what you
rebuttal.
think I'm saying.
So your rebuttal is that I can't substantiate my conception of a crystalline structure. That's
No.
basically your rebuttal. Something that I've already conceded at the beginning. You know, I already I gave you that. I granted you that.
You're shadow boxing, dude. You're arguing against
All right, go ahead.
somebody who didn't say that thing.
Go ahead. So go ahead.
When I said
no pressure, 40 psi one side and 0 pressure the other side. That's what he's asking.
Yes. Did you get that? He got it.
No, I didn't hear. I could barely hear the guy.
So I'm not asking you to show me the crystalline structure. I'm saying just as when I was asked to demonstrate a container that has a vacuum at one end and pressure at the other, I said, okay, well, can you show me a container that has low pressure at one end, like we have just go up in a balloon, check that, very low pressure, like in the stratosphere, and 14 plus PSI at the other. Just
every container has a pressure gradient in it. You're
Correct.
missing the argument, dude. It's about pressure, not the pressure gradient. A tank of propane has higher pressure on the bottom and lower pressure on the top.
Why?
Yeah. So if
Do
you
you mean
actually
that's
get
because of the down?
if you had the right tools that could measure the barometric pressure inside of a container, or the relative density inside of a container, you're gonna have some separation. You know, there's gonna be even in a small 20-pound propane tank, there's gonna be a gradient change from the bottom of that tank to the top of that tank. But it's so fractional and so minute that you would need a precision device to measure it. But it's there. And then if you scale it up, right, to like our Atmos, there's also a gradient change. So what?
It's negligible. Nice try.
Then all you have is a hypothesis, and you need to prove you need to find data to prove or disprove the hypothesis. There's no evidence for a dome or container or a firmament. None.
right. You're conceptually abstracting out with inductive logic based on your experience with something like a propane tank and going, well, since that has a container all around it concealing the gas, this must also then therefore have that too.
There you go. Thank you.
Inductive reasoning. Your light bulb
right, that's
just
what
went
you're
on,
doing,
dude.
and it's a fallacy.
No, listen, bro.
not.
This is
That's
so crazy
how
because
science
why are you using that as a rebuttal? I gave you inductive reasoning, and then you're using it against me. I don't know if you know what you're doing right now. You don't even have inductive reasoning on your side. At least we have inductive reasoning on our side. Are you following me now?
So
though
let me get you
deductive
straight.
reasoning, hold on. Though deductive reasoning can be more powerful because it requires experimentation, verification, right? You don't have neither. At least I
You're
have
using a false
inductive
dichotomy.
reasoning on my side.
Well, I
You
have
you
direct
have
experience, direct
it's a
measurement.
false dichotomy, by the way. It's not because it's not one or the other. You have to prove your hypothesis, or you have to at least observe or do some experiment that either falsifies or validates the hypothesis of a container in the atmosphere. Flat Earth hasn't done that. You're still at the hypothesis, and what you're
Yeah, not
doing.
everything has to be deductive in order to be true.
No, exactly. But you saying, okay, we can deduct it based on the what is it, Occam's razor? It's not
No, he said
one
we
or
can
the other.
induce it. He said we can inductively come up with it. So, what is your inductive argument for the gas pressure gradient?
Okay, it's like maybe let me try it like this. I don't know if this will work. I'll take a shot at it. As we go up in altitude, gas pressure decreases. Can't I inductively deduce that if I continue further and further, it will decrease further and further?
That's begging the question.
Well, if you add just one thing, as you go up in altitude,
No, I think
the
that's
pressure
inductive.
decreases without a container.
If every time I go up, the pressure goes down, every time, then I can induce.
And how do you know that? How do you know that? How have you gone up
We measured
everywhere in
We
the
measured
universe?
it.
You haven't
measured
gone
it.
up everywhere in the universe.
We measured it.
Okay. Well, I'll
No,
debunk it just simply
no,
like
no, no,
this.
no. The
If I
answer
go,
is
no, let
every
me
time
debunk it
we've
for
gone
you just
up,
to
the
show
pressure
you.
went down.
No, that's not true, okay? Because if you go up far enough and you go to the moon, the pressure starts to increase again.
Because of the moon.
Okay, well, there you go. You just made an entire claim that as I go up, the pressure goes down. That's not true.
Yeah.
Well,
No barrier in between, though. No barrier in between the moon and the Earth. So where's the firmament? Where's the dome?
The surface is drawing the attraction. So, yeah, I mean, if you're in the middle of the sky, you don't have anything attractive body, it attracts. So that's why you have that temperature variance from just being in the middle of nowhere when you get closer to the surface.
And mass attracting mass.
Okay, then correct your argument. Obviously, it's not when you go up, pressure decreases.
I think that's a horrible straw man,
If you're going to
bro.
give me the moon, if we went to the moon, then we went out, then we had direct experience with the vacuum of space.
Okay, how do you know the container is not beyond the moon?
How do you know that it is?
I didn't make a claim that it is.
You said that they got closer to the moon and it changes. You said that. So what are you talking about?
That's in your model. Am I not correct? Isn't that what your model states?
I don't know. You brought it up.
So now you're saying you don't know.
Oh, you brought it up.
Wait a minute, guys. Wait a minute.
I'm steel manning your model, bro.
Yeah, too much clipping, bro. Hardly hear.
From who? From me?
My bad.
I can hear him fine.
So when we were on the moon, we looked at the Earth and saw that it was a sphere and there wasn't a dome. That's
yeah.
we're good.
And before we actually go into a rabbit hole and deny everything about the moon landing and and go into this infinite, I don't believe this, therefore it must not be true hole. What can we agree on? And let's go from there.
We can agree that you should try to prove the moon landing. Try to prove it to me what they want.
Yeah, exactly. So, yeah, okay.
We agree
fair...
the gas pressure decreases as elevation increases. Right?
Yeah, but that's not their point. Their point is that at some point, whether or not it decreases over time, at some point for flat Earth argument, there needs to be a barrier, and even in a closed container, there is a gradient. That's what they're saying, right? Am I right?
Not all flat earthers, not all.
No. Of course.
Yeah,
but just
everybody.
I'm just trying to understand your argument so we can get somewhere instead of going around in circles, because You know, if everybody starts pointing fingers at each other for, you know, fallacy here, fallacy there, then we're getting nowhere, right? We can all agree on that. Okay, I guess that's a yes. So let's see. Like,
I will
okay,
point out fallacious logic. I'm sorry. That's
yeah, of
just
course. No, that's perfectly fine. Perfectly fine. I totally agree. I do that too, right? Both sides have to be, you know, solid arguments, right? But can we agree that, like, do you adhere to the scientific method? Yes or no? Do you believe in science?
I don't believe that it's the only way to obtain knowledge.
Okay,
Me too.
what is the other way to obtain knowledge to you?
Reasoning.
Okay,
Rationale.
reasoning. Okay, rationale.
Experience.
Okay, so personal
Yeah,
experience.
science can't determine knowledge on like events that don't repeat themselves. You need something that's repeatable.
Of
If
course, yeah.
something's not repeatable,
Mhm.
science can't even know about it. It can't even make a
Okay.
determination on non-repeating events.
Okay,
Like
so if something.
you can't scientifically determine if JFK got shot in the head because you
No.
can't just bring back another JFK and
Okay.
another shooter like and
Okay.
reproduce the thing.
Okay. Of course. No,
Good
you
point.
can't do that. But we're drifting on into like conspiracy. You know, I don't understand
That's not a
that.
conspiracy. That's just how logic works. That's how the
Yeah.
scientific method works. That's how the guy who made the scientific method said,
Okay.
I'm going to make this and it's going to tell us certain types of truths about the universe. It can't tell us every truth about
Mhm.
the universe.
So, Psyop, do you then claim, or do you agree? Let's not use the word claim, but do you agree that the scientific method is basically, if you can observe it, if you can measure it, if you can repeat it, then you accept it?
The scientific method as a experiment. Yeah,
Yeah, of
experiment
course.
is the most
Yeah.
important part.
Yeah, exactly. You experiment and then you look at the data and see whether or not that agrees with your hypothesis. Correct?
Yeah, you have a cause and effect relationship. You change the cause and the effect is affected the same way every time. And so you can make a that's what it determines is repeatable cause and effect relationships. Everything
Mhm.
outside of that cannot be even there can't even be a scientific claim about it if it's not a
Yeah.
cause and effect repeatable relationship.
Yeah. Okay.
You
So there
can't
have.
scientifically determine if someone went to the moon because that was like a one-time event. It's not
Okay.
it's not a natural phenomenon.
Okay. So, for example, the Cavendish experiment. That's something that has been done many times before, right? And that is an experiment that to measure the gravitational constant, right? It has an independent variable, a dependent variable, you know, and you can also control the other variables. And do you agree with that experiment? What it showed?
My understanding is that the independent variable is the mass of the balls or something like that, and the
No, just
dependent variable is the torque on a wire or something.
yeah, almost. Yeah, the independent variable is the distance between the masses, and the dependent variable is the torsion angle of the fiber. So the angular displacement of the torsion balance is measured,
I thought
which reflects.
the amount of mass
Mhm.
was important. Wasn't it's the distance? Okay, maybe I was wrong about
Yeah, the separation between the large and small masses is varied or set to observe its effect on the gravitational force. You know, so you know the control variables are like the masses of the objects, the environment, you know, vibrations, temperatures, changes, whatever, and then the properties of the torsion wire, you know, the stiffness and stuff like that. So if we change the variables, right, and we control them, right, and then we measure the independent variable, right, and the dependent variable, then we can agree, like, every single time the gravitational constant is the same. So whereby you actually showed that mass attracts mass. So if mass attracts mass, because the Cavendish experiment, you know, showed that, we can also say that, okay, air molecules get attracted to the Earth molecules, and the Earth is way more massive than the atmosphere. So by logic reasoning, you know, you can infer
That's
that.
inductive reasoning.
Yeah,
Yeah,
sorry,
that's
inductive reasoning. Yeah, so by inductive reasoning, you can say, okay, the Earth is attracting the atmosphere towards it, right? Now, if you go about the shape of the Earth, well, we can measure that too. And there's there's thousands of evidences that you can, logically, deductively reason yourself into a globe Earth to. I have yet to see a flat earther show me any flat Earth measurements. And like I've asked for them, and it's either met with deflection, running, or ridicule. And that doesn't get me.
Hold on, one thing at a time.
Yeah, one thing at a time.
Hold on.
I
Wait,
was.
Noah, you gonna
well,
respond to that? Hold on. So, I'm just trying to mod you because this guy, he's just.
No, you go
Alright.
ahead, Lion. I gotta do some
If
shit.
I'm going too fast, I apologize.
Go ahead then, Flat Monkey.
Just real quick, it's like he's making the claim of the globe, and then he's asking us for evidence of a flat Earth when, like,
No.
we're just stating what we see. You know, like we're not making the claim. It's just
Okay.
the actual reality of it. Anyway.
Okay. So what you see is that are your eyes a good tool to measure things? Because my eyes are like they can't even see a 1 degree tilt in 10 feet. They can't see that. Can you see a 1 degree curve over 69 miles? I can't. I'll admit to that. Our eyes are not good tools to measure the shape of the Earth.
What we can do. We can hang plumb bobs not too far from each other, right? And we can measure them to be parallel. Is that good enough then?
Well, hold on.
Yeah,
So
see,
he
that
said
has
1
been
degree
done.
of curve
That
over
has been
69
done.
miles. If there's only 1 degree of curve over 69 miles, that debunks the radius value, dude. For
No.
the circumference
That's
or whatever.
exactly what we need for 360. If it's going 360 degrees around, you get the 24,000. How many miles is it that the Earth is in circumference?
Yeah, 69.
Yeah, but the relationship between the circumference and the diameter is a 67%, right? So, or 63%. So what you have is the distance traveled along a curved surface is like you have 63% of that would be traveled along a straight surface, right?
What do you mean 63%? Are you talking
relationship
about water?
No, I'm talking about circles.
Yes. What about it?
So yeah, there's a relationship between the diameter and the circumference, correct?
Can you tell me that relationship?
Yeah.
Oh, you don't know?
Pi.
Man.
No, I don't know. I've never heard about that before.
Okay,
Sorry.
like this guy's troll. Listen, buddy.
I'm not trolling.
Don't play games, okay?
Montreal, are you there again, dude? It's telling me that I'm trolling. Seriously, dude, you did this last time.
You don't know the circumference, the relationship, and what he just asked you. You don't know that?
Well, I know that C equals 2 pi r. I know that.
Okay, so please, let's not just ask questions for no reason and go around in circles. It's kind of aggravating.
Yeah, but don't freaking like you last time you strum at me and you said I was a troll. So you're trying to point to the well. So don't do that, please.
I said it's trolling behavior when you know the answer to a question and you ask it. That's all I said. So let's just
No, I didn't
stay in a
know it.
convo. That's it.
I did not know it. I just looked it up. I am honest about
all right.
that.
Okay. Well,
My bad. Then you learned something today. Okay.
Exactly. Yeah, I'm learning all the time.
Okay, if you understand that relationship, right, which is 2 divided by pi.
No,
right?
2 times pi.
Yeah. No, I'm saying
the circumference is 2 times pi and the radius
Yeah, so then you have 2 divided by pi. It gives you a 63% drop over the distance.
What do you mean 63? Wait. I don't understand the thing that you just said. How do you get to that?
I just reversed what you're claiming here. If we consider the curvature rate of a circle as a universal constant. Okay.
No, yeah, what's the opposite of multiplication, dude?
Yeah. Wait, so you want to calculate for radius then?
No, I'm not calculating for radius.
I mean, first you're calculating for
problem, in
circumference.
fact.
You want to calculate for radius now?
No,
Or-
dude,
no.
I'm saying
or-
I'm showing you the relationship between the diameter or radius and circumference of a circle. So we could think of curvature rate of a circle as a universal constant.
Yeah, so you're doing radius equals circumference divided by 2 pi, right?
No, dude, no. I'm explaining the relationship between the radius and the circumference. Why are you not understanding that?
You're the one who said you didn't understand it. Let him explain.
So in this context, the curvature rate of a circle can be seen as a percentage drop in the distance traveled along the circle's circumference relative to the distance traveled along a straight line.
Okay. So tangent.
So yeah, we have a 63.66% is the distance traveled along the circumference rather than traveled along a straight line.
Okay. So that's the drop, basically.
So yeah,
of
so
this-
at so 5,000. How many feet are in a mile?
I don't know. I have the metric system.
So like,
Sorry.
okay, all right. So let's just say there's like 5,000. I can't remember exactly what it is, but it's like 240 feet or something like that in a mile.
Okay.
63% would be on a straight line. This doesn't. This doesn't add.
What do you mean 63% would be on a straight line? How are you coming to that conclusion?
Regardless of a circle's radius, the distance traveled along its circumference will always be approximately 63.66% of the distance traveled along a straight line.
And where did you get this? Like based on what you
This is what circle. This is stuff you learn in the 8th grade.
I went through 8th grade and I don't know what you're talking about either.
Yeah, exactly. Like we don't know. Is it the way you're saying? Like I don't know if it's the way you're saying it or like can you give me like an image that explains this what you're saying so you can visualize it, please?
Okay, if you understand, like, you can give the curve by 2 divided by pi because of the relationship. This is, you could take 2 times the diameter divided by the circumference. You could do the 4 times the radius divided by the circumference. You get this interesting number that appears in all circles of 63.66.
How do you get 4 times? What did you say? 4 times the what equals what?
The radius.
4 times it. Where do you get 4 times the radius?
4 times the radius divided by the circumference. These are just other ways to describe circles, dude. To describe the curvature rate of the circle.
4 times the radius divided by
geometry, dude. 8th grade geometry.
Yeah,
granted,
so
we all need a refresher course, but come on, dude, we're talking
Yeah,
about
I need a refresher
pi
course
and
apparently.
circles.
Can you go back to the?
That's the problem with Globers. They think they know math.
How do we find the volume of a cylinder? Like, come on, dude.
Where does
What's
the straight line come in on
there?
the curved surface again? Or did I hear you wrong?
No, it's just it's a relationship between the two of what a curved surface versus straight line. You have a 63% difference in the two. Do you understand that?
I will here. I looked it up, and it says you can tell me if I'm correct. If you calculate 4 times the radius divided by the circumference of a circle, the result will always equal 2. This is due to the relationship between the radius and the circumference. Is that what you mean?
Yeah. Yep. Exactly. And then
So
yeah.
yeah.
Or you could just do 2 divided by pi for simplicity, like what you just explained.
2 divided by pi is not the same as 4 times the radius divided by circumference.
No,
though.
he means 2.
Go ahead and do it. Go ahead
pi
and
r.
get any circle you want.
Oh,
and plug
2
them
divided
all.
by pi, and that is 0.63. That's what you mean, right? So this is a constant ratio for any circle, regardless of its size.
Yep. There you
Okay.
go.
So, that's what you mean. Okay.
Yep.
Now I understand. Okay. Good. Like this is okay. Yeah. This is just.
What was the context of the purpose of bringing up that ratio?
Because there's a 1 degree per 69 miles, right? Of curvature, right?
Yes.
So then you what this ends up doing is you end up learning, where did a mile come from?
Okay, continue.
Yeah, so where did it come from? Go ahead.
Where did it comes? I think it came from I don't know. You want to know?
I thought it was all remeasured by that guy who fucking determined the border between Canada and America or whatever.
What?
Aries.
It comes from the Roman
Doesn't this go back
Empire.
to Eratosthenes?
Here,
Yeah, yeah.
one Roman mile is 1,000 paces. So
Right.
it comes from the
So it's
Roman
not
Empire.
high observance.
Nah, son, they had cubits before Rome.
That's not the point.
So what's your point? What's the point here?
Right. The point is that they use the ground, not the sky. They use footsteps.
Okay.
Yep. And do you think they got the same measurement that we have now with footsteps?
Are you using the same metric?
Nah, they got different measurements from what I remember. There's statute miles, and then there's nautical miles.
Yeah,
Can we get to
nautical
the point
miles.
at some point? What's the point?
The nautical miles consider the curvature of the Earth. Statute miles do not, from what I remember.
The mile is defined as 5,280 feet, and a feet is defined also universally how long that exactly is.
Which is based off a 6-foot man.
I don't know. Is it?
Yeah, it's a foot of a 6-foot man.
Are you talking about
Dude, I'm
looking at
pretty sure that when I was watching that Ares failure movie, they were saying that this guy redetermined all the measurements and redefined all of them when he came through.
No, I just looked it up. The metric in terms of the American system is 12 inches, and then you can just go smaller and smaller and smaller. 12 inch. What is an inch? So we're regressing
It's just a
into
division of a
smaller and
foot.
smaller. Yeah, it's just we're regressing into a smaller and smaller thing. Now, like, what's the point?
So what you're gonna find out, what you
Okay.
find out is circles don't exist. Yeah, this mathematics doesn't even. None of this even exists in reality.
Excuse me.
And
What the fuck did you just say? What the fuck did you just say?
And then you're telling me the mathematics.
Circles
are the
don't
reality.
exist now. Circles don't exist.
There is
Look at
absolutely
your
no
profile.
circle in reality, bro. You cannot find
Yeah,
one thing
we're
that has
talking-
equal distance to
Can
its
you look
side.
in Discord? Aura, no, wait a minute.
Stop. Everybody stop.
Real
Dude.
quick.
What the
Let me
fuck?
say something, dude. A circle is a two-dimensional concept that does not exist in three-dimensional reality. In case you were unaware of that, here's a newsbreaker for you.
It does.
Okay, so then
A circle
when we see,
exists
so then
in two-dimensional reality, which is a concept. The second you bring a circle into the third dimension, it's no longer a circle, is it?
It's a sphere. Yes, it's part of a sphere.
No, not even a sphere. You could consider it a ring, maybe, because there's
Yeah, it's a ring.
dimensionality
Yeah.
to it.
What
Yeah.
do you think the
So when he
equator
says-
is?
When he says
Well-
circles don't exist in reality, show me a circle in three-dimensional reality, please. Thank you.
Okay. Do you think that? Okay, so
who-
3D. Wait a minute. 3D is not reality.
Nah, you got that backwards. We live in a three-dimensional reality.
Yeah,
and
exactly.
You're using two-dimensional. You're using two-dimensional concepts to reify three-dimensional reality. That's the problem he's saying.
Yes,
No.
exactly.
What is-
This
hold
the
on,
whole
hold on,
point,
hold on,
right?
hold
Hold
on.
on, let me just explain this. The reason you're taking 3.14, 3 happens to be the number, is because you're trying to transform it to 3D reality.
No.
No, I was just gonna say, stop clipping.
what does this
Who's
all have to
tripping?
do with what he said about the 1 degree of curvature over 60 plus miles?
Yes.
Go ahead.
But
Go
it's
ahead
measured
and
in.
figure it all
But
out for yourself then.
But
If
it's
a
measured in.
63% relationship between a straight line and a curved line along that circumference. Go ahead, see if that adds up.
Okay. Let me.
Go
I think
do
it'd be closer to
measurements in your backyard,
64%.
bro.
Okay. Wait. Let me.
What?
Let me get my PowerPoint up. Just give me a second.
Go ahead. What? That's your answer is go ahead. So we
I didn't say
went on
do it
this
in a
rabbit
computer.
trail of like proportionalities and circles don't
I
exist in
didn't.
3D.
Hold on. I didn't say do it in a computer. I said go out in the real world and prove that.
Yeah, we
Go
already
out and
did.
measure the
We already
ground.
did.
Nobody has ever done that. See,
Yes, we did.
think about this. In order to measure 24,901 miles, right, around the equator, go ahead, explain to us how you'd get that measurement.
Okay, I will.
You don't get to use
Give me a second.
GPS, you don't get to use anything. You're just a
Well,
man.
what they do,
Oh.
Tor, is they use the RPM on a motor, and they use gas. They calculate gas mileage, but they never take an actual tape measure or something physical and tangible to stretch it out across the surface. They won't do that. They never
No,
done that.
We
because
did.
they
We
can't
did.
do that.
I
If they do
actually
that,
have
they
that.
won't find the 63% relationship that's
Oh,
required of every
no,
circle.
we
So
did.
this is what is interesting about this is when they say RPMs or this and that, well, the water moves. So you don't so you could be going the same speed with further RPMs depending on the direction of the current.
Actually,
There we go. This isn't the first time I encounter this. We have no
Do,
idea
do,
how fast
do
we're
you
going on
realize?
water.
Do you realize that a calculation is not a measurement? I mean, can we
No,
agree to
we
that
did
at
a
least?
measurement. We did a measurement, actually, like a measurement. Straight line,
Can we
0.8, point-to-point measurement proved the curve. Like, I can show it to you.
Can we
I'm looking for
agree?
the...
Can we agree? Can we agree a calculation is not a measurement?
Oh, yeah, sure, yeah. But, like,
Okay.
you do know trigonometry, right, Joe?
Sure, yeah.
Okay, and you know about inductive reasoning. I heard a flat earther here talk about it. Like, I think it was...
Okay.
Yeah, so we can use inductive reasoning, right?
Yeah, but what are you inferring with your inductive reasoning? You have to have something
Okay. Yeah, I'll show it to
substantiated
you.
to infer something.
Yes. And I'm looking for it right now. I'm looking for the PowerPoint that I can show, or maybe I can show because I don't know if I can share my screen on here. I don't know.
Well, I just wanted to say, I think that with where this conversation has gone, we should really take it all the way back to the laws of logic. Because, it doesn't even seem like this guy totally understands, not trying to be offensive or anything, but it doesn't seem like he totally understands, why they're there. Why they are.
I mean, I love me
Well,
a
as
good
long as he
logical
has
fallacy.
a trigonometric, as long as he has a trigonometric function in lieu of an actual measurement, I think he feels comfortable. So,
Well, I've also literally observed it. So, I mean,
No, you haven't.
yes, I
How?
have. By just, like I said before when I was here, went on the beach, right? I know where I was, right? On the planet or on the Earth, right? And then I looked at the horizon and I saw objects at the horizon that were at a set distance, right? Like a windmill farm or something like that. Then I looked at the distance and then I used a globe model and a flat Earth model and predicted, and those both predicted what I would see, right? And then I went up on an apartment building on the ninth floor, something like that, eighth or ninth floor, and then I did it again. So I incorporated the independent variable was the altitude that I was looking at the horizon from, and then I viewed again what I would see on a flat Earth and what I would see on a
so
globe Earth.
you're talking about long distance optical observations. How did you account for refraction across the entirety of that corridor from your physical perspective?
Not only that,
I
to a
took-
non-physical location. He did it to a
No,
non-physical
Tora.
location called the horizon.
Tora, you need a physical horizon for there to be an apparent one.
Hey,
That's a Nathan Oakley trick, and I know that trick, and it's
Let's
not gonna.
go.
It's a logical
hey,
fallacy.
just to be fair, real quick, to respond to Flat Monkey regarding the philosophy, you can make an inductive measure with pure observation. Like you can make a measurement and gauge a distance. Like if you need to jump a gap, if you're skating and you jump a gap, you can make an observational measure. I know some people disagree with that, but I would say
it's possible.
On that point,
Actually, there is a. Sorry, somebody's breaking up really. Like
you're
a
a
lot.
robot guy, so. But I
Joe
was going to
King,
say on
you're-
that point, they do measure the flattest things they know of on a small scale, being they're like granite tables, but they have to be perfectly level, and they use their eyes optically to check the levelness of them.
Absolutely.
And so on a small scale, I agree with you, but on a large scale, it's hard to I don't know. Hard to fathom.
To make a judgment, to measure somebody, right? It's to make a judgment call. You can do that without having tools at hand or physical like measurements where you actually have a ruler or a tape measure. You get what I'm saying?
Yeah, if you look at the live stream one text, I posted the proof of Earth curvature, the Rainy Lake experiment. They did measurements, stepped measurements with refraction values measured, the measured height, right? And then they incorporated refraction, right? And then they compared it to both models, the globe model and the flat Earth model, and the globe model actually matched the predictions that they made. This validates, so in essence, this validates the globe model and falsifies the flat Earth model based on observation and refraction.
No, dude.
Yeah, but the thing is,
you misunderstood. Hold on, let me get this in. My battery's about to die. What I asked you to do is go in your backyard, right, and take a string, make a straight measurement, and then the measurement of the ground. They have to have a 63% relationship to them.
Mm-hmm. Yeah.
So over those 5,000 miles, there's a 63% relationship between the straight string, or 5,000 feet. There's a relationship between the straight string and the line on the ground that you walked of 63%. You won't find it anywhere.
We do.
Yep, it's not found.
It is. Why do you say it isn't?
Oh, but yeah, so physical measurements are more reliable. Right?
Yeah, and these are physical
standard
because we measure the Earth with
credibility.
straight line segments.
It's more it's a higher certainty, right? A physical measure, and there's a difference between first order and second order measurement.
Yeah, these are all first.
But you're appealing to really, really weak observational measurements, dude. With optics that are prone to refraction and
and refractions included,
and controls that you can't account for.
You can account for them. We know.
Even actually have a measurement. You have.
We do. Look at the link that I just posted.
An observation to.
Why are you interrupting?
Can you guys hear me?
Yeah, go ahead, Jimmy. Just click.
Yeah, that's not even the Rainy Lake shit. It's not even a measurement. You have an observation or an apparent position and no measurement of which way the light's bending.
Yes, we do, because they measured the temperatures.
That is not a measurement of which way the light's bending. That's a measurement of temperature, my man.
Yeah, and based on that, we can infer the refraction coefficient.
Did you measure the which way the light's bending, or did you just
temperature
guess
gradient,
on which way?
temperature over height?
I thought you were done, dude. My bad.
No, it's okay. Temperature gradient dt over dh. That's that. Because of that, you can have a refraction coefficient. And it has been done.
You haven't measured. My bad, dude. I thought you were done again. Go ahead.
That's okay. It's okay. So, you can
say over and out when you're done. Say over and out when you're done, because I can't tell.
I will. Now, if you look at the predictions, right, and then the refraction was about 0.27, right? And it's slightly more than the standard refraction. Now they measured that by measuring, I think it was, let me check, because this is a whole experiment with several pages.
Dude, we're trying to have a back and forth here. I mean, you've been going for a while now, and you're like
okay. Go ahead.
Stuff up in the middle of you talking. Can you please be concise?
I think it's your turn, Jeremy.
Yes. Go ahead.
You don't have a measurement here. Measuring temperature is not measuring which way the light's bending. Measuring which way the light's bending would be a geometric question of angles and something to that sort. Measuring temperature is not that. And you don't know that's the way the light's bending because you've never measured the way the light's bending over that distance based on the temperature and pressure and humidity.
Give me a second. I'm looking up. Give me a second.
Yeah, you don't have a. Can you agree that measuring the temperature is not measuring which way the light's bending?
If you know if you know the temperature and the height or the pressure or whatever, you can know how much the light should be bending based on the temperature differences. You can use Snell's law.
So you don't, but you're guessing that there's no other variables at play, and you've never actually measured it, so you don't have a measurement. You're just guessing, and you think maybe this is probably the way it works. We don't know though. We don't have a measurement.
Well, based on those laws, we can create models, and then if we make a prediction and then reality matches the prediction, which it does, we know that the model is correct. That's how you do. That's the same. No, you don't presume anything. You make a prediction, a hypothesis. That's the scientific method.
I don't know.
Which I said earlier. Like you have to make a prediction. Otherwise, you have to assume something. No, it's not a presumption. It's a hypothesis. You hypothesize that the light will bend in a certain way over distance that much. And then you do the experiment, you measure, and you make a model based on your experiment. If the model then agrees with reality...
Hypothesis. Come on, guys.
Yeah, exactly.
Trying to have a back and forth real quick.
Because refraction is not a constant phenomenon. It's like it varies all the time, right? It fluctuates, but you can take still images, right, and do the measurement at the exact same time you take the still image, and then you can base your model based on that. And if your model is incorrect, it won't match with reality. But it did match with reality, and it matched with the globe model. Reality matches with the globe model. So that for me is a validation of the globe model. If you want to falsify the globe model, you have to prove that with observations. You have to make a hypothesis, do an experiment, and then show that your model...
bro. Just make a quick.
Do you have... Okay, then show me a model that show me a refraction model that disagrees with the globe model. Show me a flat Earth model that actually that is valid.
I think Jeremy wanted to say something, Wave Seeker. I don't know if you want to pause for a moment, take a breath.
Of course.
Regather your thoughts. Jeremy had something he wanted to say.
No, I don't want to have a back and forth with that guy. I'm good.
Nah.
Let's get into Wave.
That's what I thought. That's what I thought.
He's whack. It's because you're whack. It's because you monologue.
No, it's because you know I have a point. That's because of how it works. That's how it works.
No, it's because you're not a good conversationalist, is what he's trying to say. And you can gaslight him on his reasoning, but he's telling you it's because you're not a good conversationalist.
It's because you're monologuing. It's because you're monologuing and you're not addressing the point that you don't have a measurement. You just keep saying saying we have laws. You just keep saying we have laws, we have measurements. You don't actually have a measurement. There are other things. Hold on a second.
He don't stop.
Okay, I got it. You have laws, which there can be other forces at play and make your laws not act appropriately. And just having that, there could be other variables there that would make the light not do what the law says. If there's another variable there that is unbeknownst to you, which is why you would need a measurement of which way the light's bending. It's a geometric issue. There's no geometric measurement here. You have no measurement of which way the light's bending. You don't. You have an idea, and maybe it's like that, but you don't have a measurement.
There you go. Just posted the measurements. You're welcome.
You don't have a measurement.
You've never measured which way the light's bending. Just posted it.
How do they measure which way the light's bending? By measuring the temperature? That's not a measurement of which way the light's bending. Newsflash.
Snell's
I'm familiar with the Rainy Lake experiment.
Snell's law.
I know, and there's a law of gravity that says things could fall down, but I could apply other forces to make things not fall down.
Yeah,
so just because there's a law saying something, just because there's a law saying something should happen, just because there's a law saying something should happen. Hold on, man. What's going on?
Who's hot micing, bro? Or clipping or whatever.
Jeremy's the authority on this, so we have to listen to him.